Hey everyone, and welcome. Right now, Australia's most vital industries, think mining, construction, the real heavy hitters, are standing on the edge of a massive revolution. And you know what's driving it? A single missing piece in AI that's about to turn automation from just a simple tool into a true thinking partner. So, what is this missing piece? Well, let's dive in and find out. All right, here's our game plan. First, we're going to uncover what this missing piece actually is. Then, we'll look at how it's basically creating a predictive crystal ball for industry. After that, we'll get into the real world changes we can expect in the next 2 and then 5 years. And finally, we've got to face facts. We'll look at the very real roadblocks standing in the way of this future. So, first up, let's pull back the curtain on the key technology that takes simple automation, which, just knows where things are, and elevates it to true intelligence, which actually understands what's going on. Okay, so this is the central question, right? What's that secret ingredient? What is the one thing that takes AI from being a dumb, pre-programmed robot to a genuine partner that can think, adapt, and operate in the real world? The answer is something called spatial intelligence, or SI for short. Now, this isn't just about knowing GPS coordinates on a map. No, this is way deeper. It's about the AI having a real, almost intuitive grasp of its environment, the context, the physics, the relationships between all the objects in a 3D space. It's really the difference between just seeing a location and truly understanding a situation. And this slide just nails the difference perfectly. A simple GPS? It knows a truck is at point X, Y, Z. That's it. But an AI with spatial intelligence, it knows the whole story. It understands the truck is on a narrow, muddy road right next to a dangerous 10-meter drop-off, and oh yeah, it's carrying an unbalanced load. That's not just awareness. It's practically digital intuition. But of course, this kind of intelligence needs a powerful engine to run on. And this is where a technology you might have heard of, the digital twin, gets a radical upgrade. We're talking about transforming it from a simple monitor into a full-blown predictive crystal ball. Just look at the leap we're about to take here. Today's digital twins are basically digital shadows. They're great for answering one question: what is happening right now? But the next generation, the cognitive digital twin, it's more like a digital oracle. It can answer the real money question: what's going to happen next? And it can do that because it understands physics and can simulate the future, turning itself into a training ground for the AI. So what powers this oracle? It's a technology called a world model. And I love this quote because it puts it so well. The world model is the cognitive engine that turns that digital twin from a reactive history book into a proactive, predictive crystal ball. So how does this thing actually work? Well, it's a pretty straightforward 3-step process. First, it perceives the world, just soaking up massive amounts of data from sensors, video, LiDAR, you name it. Then, it uses its built-in understanding of physics to simulate thousands of possible what-if scenarios. And finally, it analyzes all those simulations to predict the most likely future outcome. It's pretty amazing. Okay, theory is great, but what does this actually look like on the ground? Let's talk about the predictive phase. The real, tangible impacts we can expect to see in just the next 1 to 2 years. The first and maybe most important impact is going to be on safety and maintenance. I mean, we're talking about making some of Australia's most dangerous workplaces dramatically safer. Why? Because this tech can see a catastrophic failure coming long before any human ever could. And here is a perfect real-world example. A sensor today might just give you a reactive alert. Brake pad is at 20%. Helpful, but limited. A system with spatial intelligence, though, considers the context, that muddy, steep terrain, and gives you a truly life-saving prediction. Hey, there's a 95% chance of catastrophic failure in the next 72 hours because of these conditions. That's the difference between a warning light and a crystal ball. The second huge application is an autonomous inspection. We are moving way beyond simple data collection, where robots just take pictures, and into a new era where they actually comprehend what they're seeing. Just think about what this means for a second. Instead of a drone just dumbly flying a preset path, snapping photos, it uses its world model to understand what it's looking at. It can actually tell the difference between some harmless surface rust and a critical load-bearing crack on a weld. By only flagging what actually matters, it saves literally thousands of hours of wasted human inspection time. That's a game changer. Okay, let's zoom out a bit further to the next 3 to 5 years. This is what's being called the generative phase. This is where AI isn't just predicting what's going to happen, it's actively creating solutions and collaborating with other machines. So, the next big evolution is moving beyond single, isolated machines. The future is all about creating collaborative fleets, entire teams of robots and vehicles that can work together seamlessly on a single coordinated mission, kind of like a well-drilled human crew. Imagine this, a squad of machines on a job site, an excavator, a few haul trucks, a survey drone, all working in perfect concert. Their individual world models are constantly talking to each other, predicting each other's moves to avoid collisions and just work at peak efficiency. But here's the real mind-blowing part. They can adapt instantly to a high-level command given in plain English, just like a human foreman would give. That is incredible. Now, this all sounds absolutely amazing, but we have to ground this vision in reality. The path forward is not simple. There are some significant real-world challenges that we absolutely must overcome first. Yeah, the path to this future is not exactly a smooth highway. There are four major roadblocks. First, you've got connectivity. These systems need massive, super reliable bandwidth, often in the most remote parts of the country. Second, the skills gap. We desperately need a new generation of what you might call AI wranglers. Third, regulations. I mean, our laws were written for humans, not for robots. And finally, maybe the biggest hurdle of all, safety validation. And if you want to understand the urgency behind all this, just look at the numbers. Australia is estimated to be short 90,000 workers just to meet its housing construction targets. This isn't just a small problem, it's a full-blown crisis. It's why this kind of automation is no longer a nice-to-have, it's become a national imperative. And those regulatory hurdles, they are just as massive. That number you see, $20 million, that's often the minimum public liability insurance you need just to trial an autonomous vehicle on public roads in Western Australia. It's a pretty stark reminder of the immense financial and legal risks involved before these things can even leave the lab. And, this skills gap is really two-sided. On the one hand, we have a massive shortage in traditional trades like welding, which automation can help with. But at the exact same time, we're creating this huge demand for brand new jobs that don't really even exist yet. Roles like digital twin architect and robot fleet supervisor. We need to start building that workforce, like yesterday. And this all brings us to the final and most critical question that underpins this entire revolution. When an AI is making life or death decisions inside a black box that we can't fully see into, how do we, and how do our regulators, prove that it's truly safe before we hand over the keys to our most critical industries? That right there, that's the challenge we all need to solve.